this time I'm going to teach you how to sketch graph square root function. Okay, this is the general form. Let's say square root of linear function inside here. The general form for the square root is same like the pattern square root. Okay, square root, square root, square root. Okay. Just easy to remember the pattern of square root. The graph is like square root. Okay, so let's say the function is given y equals x. Okay, when this one is positive here, positive, and x, the graph is like okay. And when x is negative here, the graph is reflected by x-axis. So the graph is like this. Okay, when x inside here negative, means that the graph is symmetry of the y-axis. Okay, then when the y is negative and negative again, the graph is reflect to x-axis. This is pattern generated for the formula is okay. Look at the first example. Given that function square root of 2x minus 3 or sed 2x minus 3, to find the domain is everything below sed should be greater or equal 0. So everything is 2x minus 3. So 2x more than or equal 3, or x greater than or equal 3 over 2. Okay, using the number line to show the domain. Okay, here is 3 over 2. Starting from 3 over 2 onwards to infinity. This is the domain for this function. So we're going to sketch the graph according to the given domain. So this 3 over 2, let's say this is 0. Okay, at the y-axis. Okay, then this is x-axis and 0 to the dotted line. This is point 3 over 2. Means that the graph is just on this side. Okay, this is the graph. No graph on the left hand side. And to find the graph, just substitute this value 3 over 2, then get a 0. The first is 0. You know the graph for sed, the pattern is same like sed. Just sketch the graph. This is the graph. Domain is from 3 over 2 to infinity. Then range for sed always positive. The range is starting from 0, y0 up to infinity. No graph below x-axis. You can say the range is from 0 included to infinity. And for the first example. For the second example, given this function 1 plus sed 2x minus 3. Okay, the domain is same procedure. Everything below sed should be more or equal 0. So domain is from 3 over 2 onwards. And then we're going to sketch the graph. The graph for this is the minimum value here is 0. 1 plus 0. We know the minimum value for this graph is 1. But still, okay, sketch the graph. Okay, from 3 over 2 domain to infinity. Substitute the value 3 over 2. 1 plus 0 is equal to 1. Okay, this is 1. And the graph is same like sed. Just sketch the graph. Same like sed. Or this graph, okay, this or the graph, the original graph, shift up to 1 because of this one plus 1. So domain of f is from 3 over 2 to infinity included, and a range of f. Okay, for range, no graph below here up until this point 1 to infinity. So range starting from 1 to infinity. Okay, settle for this example. For the third example, given the same function but the opposite side, means that the curve, the graph is flip over. The symmetry to x or y axis. Set it to x axis. Okay, and then find the domain. Domain everything below cert more or equal 0. You can say that domain is x more or equal 3 over 2. So this is the domain. Okay, and then we're going to sketch a graph. Okay, do x, y axis. Then do the dotted line 3 over 2. Then here everything the graph here. Okay, this graph suppose in this pattern. Okay, the graph is like this. Okay, then because of all the graph times negative, here negative means that the graph is flipped over. Okay, or you can substitute the value to 3 over 2 here, get 0. Substitute again, all this value times negative become negative. So the graph is like this. Okay, the graph is like this. Domain, for this one domain, we can say that domain is same domain from 3 over 2 to infinity, but the range is starting from the bottom negative infinity up to 0. So range is from negative infinity to 0. Okay, and for square root.